Let's solve a first example of application of derivative in marginal analysis. The problem says the revenue in thousands of dollars from producing X unit of an item is modeled by the revenue respect to X will be equal 20 times X minus 0.005X squared. And when I say this, and when I substitute the value of X, the number of units produced, the value that I gonna get, the revenue, will be in thousands of dollars. That's what the problem says. We are going to find the average rate of change in revenue as X changes from 1000 to 1005. And second, we are going to find the marginal revenue at X equal 1000. Let's work this problem. To get the average rate of change, remember this is the change in the function divided by the change in the independent variables. So it will be the change in the revenue divided by the change in the variable X, the number of items produced. So the average rate of change will be the revenue in the last value of X minus the revenue in the first value of X. So it was changing from 1000 to 1005. So it will be the revenue in 1005 minus the revenue in 1000. And of course, and at the bottom, make a subtraction of the last value minus the first value, 1005 minus 1000. So there was a change of 5 units in the number of units produced. So this will be the revenue of 1005. Will be just substituting in the value of X, the value of X by 1005. And here the revenue of 1000, so will be the value of the revenue when the value of X is 1000. So the average rate of change will be the revenue at 1005, so it will be 20 times 1005 minus 0.05 1005 squared. That will be the revenue when the value of X is 1005 minus the revenue when the value of X is 1000. So again the same, just substitute X by 1000. So put this in bracket because you need to consider this as a whole. So put a minus this whole. And at the bottom, obviously, this is 5, the change in the number of units produced. Use a calculator, the revenue when X is 1005, I use a calculator and I found that the value is 15,049.875. And when I substitute the value of R by 1000, so this is second expression, it will be minus 15,000. Everything divided by 5. Use your calculator for doing this. 1549.875 minus 15,000. So it will be 49.875 and then divided by 5. I get 9.975. So this is the average rate of change of the revenue. But the revenue is in thousands of dollars. So this is the unit is thousands of dollars. So this will be 9.975 thousand of dollars. The average change in the revenue is 9,975 per unit produced. This answers the first question. For answering the second question, what is the marginal revenue at X equal 1000? Remember, the marginal revenue is the derivative of the function. So in this case, will be the derivative of the revenue. That will give me the marginal revenue at whatever point. So let's find it. So B will be the marginal revenue is the derivative of the revenue. And this derivative will be the derivative of 20x. The derivative of x is 1, yeah? So it will be 20 times 1. This is a constant multiplied by a function. So the derivative of 20x is 20. So let's type this 20 and minus the derivative of the second term. The derivative of this, they have an exponent, so we'll need to multiply this exponent here. Will be 0.05 times 2, and the exponent is reduced by 1. It will be x to the power 1. So 0.05 times 2 is 0.01. So it will be minus 0.01x. So this is the marginal revenue. And to know what happened, because the question is find the marginal revenue at x equal 1000, so you are going to substitute the value of x by 1000. So at x equal 1000, the marginal revenue at that point will be 20 minus 0.01 times 1000. So I just substitute the value of x by 1000. Doing that, 20 minus 10, it will be equal 10 per unit produced, but the revenue is in thousands of dollars. So it will be, the revenue is changing $10,000 per unit sold at that point when the units produced are 1000. So because the revenue is in thousands of dollars, then we multiply by 1000. So we have 10,000 per unit produced. And this is the solution, working by hand. Obviously, a problem like this can be solved using a software. GeoGebra, for example, will be a good software for solving a problem like this. I already solved it using GeoGebra, and I'm just going to show you the answer. What was my work when I was solving this problem using GeoGebra? So I open GeoGebra and just define first the function in the input area of the calculator suite of GeoGebra. So r of x equal 20x minus 0.05x squared. So type the function, press enter. Now the function will be defined in GeoGebra. And then the only thing you need to do is just use the formula as the revenue in 1005 minus the revenue of 1000 divided by 1005 minus 1000. Just type this in the input area of GeoGebra and press enter. GeoGebra is going to give you the value. Obviously, you are who knows, not GeoGebra, that this is the unit is thousands of dollars. And if you want to know the marginal revenue, type r prime of x, and GeoGebra will tell you the answer of the r prime of x. So type enter after any input, type enter. GeoGebra know what is the derivative, and then to know the marginal revenue of 1000, just make a substitution. Just type r prime of 1000. After you have computed r prime, GeoGebra know what is r prime. And now r prime of 1000, so the derivative of r. And then substitute the x by 1000 and press enter. GeoGebra will give you the value 10. And additionally, GeoGebra is making the graph of everything. For example, when you type Rx, GeoGebra made the graph of Rx. Okay, so that gives the solution of a problem of marginal analysis. And these are two ways for working by hand or using a software. I will be making another video in which I tell you what to do if you are solving this problem using GeoGebra. Okay, I think that will be enough for this problem. Thank you and see you next time.